For our next session, this is one I'm excited about. I'm pretty impressed with this organization and everything they've done, kind of all parts of it. I think it's, again, something that we should be very proud of. I'd like to welcome up Program Manager from NGIF, Sam Ashuri.
Thank you, everyone. Thank you, Blake. The very kind words. I really appreciate that. And actually, thanks, Mila, for setting up this evening for all of us. It's a very interesting evening session, bringing together a lot of players in the methane space, technology provider. I'm glad we heard them first. And thanks, Doc, to mentioning several times about NGIF and other association. For this next 1 hour, we'll have technically 3 sessions. First, starting with an introduction about the NGIF by Akhil Abad, the CEO of the NGIF Accelerator and venture partner at the NGIF Capital, followed by an introduction about the NGIF Emission Testing Center, which is a collaboration between 3 parties. So you will hear from Tourmaline. Eamon Irvin, the Emission and Innovation Engineer at Tourmaline, will present a field operation. Ian Gates, Professor and Associate Vice President of Research at the University of Calgary, will present University of Calgary lab testing. And I will be presenting NGIF Accelerator and the commercialization support program. The next half an hour would be very interesting panel discussion between, again, Akhil Abad, the CEO of NGIF, Ian Gates, the Professor and Associate Vice President of the University of Calgary, and Scott Wilkes, Director of Emission and Innovation at Tourmaline Oil, anchoring President. The panel will be moderated with the famous Wayne Hillier from the Modern West. And I call Akhil to the stage. Thank you.
Thank you, Sam. It's working for me. Thanks, Mela and Blake, for inviting us and giving us this time slot to talk about all the things innovation we are doing here. I would begin with this announcement. Part of that, I think Blake covered, but this announcement came about 2 weeks ago. Alberta government is investing $22 million in 2 programs, essentially to do 2 things. One is to help energy companies lower their methane emissions, and second is essentially to develop new technologies needed to keep the emission reduction in the near future. These 2 programs, the first one is the Methane Reduction Demonstration Program that's been delivered through NGIF Accelerator and its industry grants program. I would go into these 2 into the industry grants program a little bit more in following slides. But essentially, this is for the startups and SMEs to test and demonstrate methane monitoring and mitigation solutions at the energy sites in Alberta and advance them to commercialization. So this is very much focused on near commercial technologies, TRL 7 and plus. And then the second program here is for the Methane Reduction Deployment Program that you probably heard earlier from Blake. It's a $22 million being put in towards that from the $29 million that's been announced. A little bit more on this demonstration program itself. This is offering up to $750,000 per project, limiting to 75% of the project qualifying expenses. Like I said, mitigation and reduction technologies, and then measurement and quantification technologies. There is a cap on measurement technologies, limiting to up to 40% of the funds. And then very much kind of focused on oil and gas operations or demonstrations at one of the operating sites in Alberta, and essentially within the NGIF kind of membership asset base. This would be delivered through 3 fixed cohorts. Cohort 1 is live right now. It's going to be essentially the deadline is 31st of January. So if you want to learn more about this program, please visit our website on ngif.ca to have more kind of information. And I think I missed that this is like a $9 million funding competition, and you might do your maths and this might not add up, just because it's been stacked by industry funding on top of the Alberta government funding. So the industry funding is coming through the industry grants program from NGIF Accelerator, and we'll go into that a little bit more. If you have any questions on this, I'm available after this, so feel free to catch me. Moving to the NGIF platform itself, our mandate at NGIF is to accelerate technologies to market and then help support them scale up through capital and industry network. That's what we do. That's what we have been doing over the last 10 years. And we do this through a couple of ways. We have a venture capital fund. It's a $50 million fund up and running for last 4 years, looking at seed and Series A investments into startups. And then we have not-for-profit arm, which is NGIF Accelerator, that delivers our programs like the Emissions Testing Center program and the Industry Grants program. These are some of the priorities. So we are big in methane, but we also look at anything and everything that relates to natural gas. So that could include energy efficiency solutions, heat and power solutions, carbon capture, renewable natural gas, and then water management and some of the other areas. The grants program, that's the program which is essentially delivering the methane reduction demonstration program as well. It's the flagship kind of fund. It's been running for over 9 years now. Next year is our 10-year anniversary. It's not for profit, it's industry-led, and with a sole mandate of advancing de-risking technologies to market. It's been designed by and for the energy companies who are part of NGIF and helps the novel technologies that reduce emissions and improve the environmental performance in our kind of members and industry kind of industrial operations. We have committed millions of dollars since its launch, and these are some of the outcomes. Over the last 9 years, we have 114 projects been approved for a total value of more than $350 million. The industry pooled capital committed is more than $30 million in these 100+ projects. And through our work, we have now 13 technologies in the market, so have moved them through different TRL stages and have them commercially available. We have 36 patents that's been generated through this funding and over 450, close to 500 clean tech jobs being supported. What I should mention here is all the industry operators which are part of the fund. We have 4 producers. We have Tourmaline Oil, who's in the room today. We have Canadian Natural, Arc Resources, and Birchcliff. All of them are based in Alberta. And then we have natural gas utilities. We have ATCO and Apex Utilities based in Alberta. We have FortisBC and Pacific Northern Gas based out of British Columbia. Enbridge Gas in Ontario, and then Sask Energy in Saskatchewan. All of these and the leadership from this group has been instrumental in making us do what we are doing to advance innovation. I know the subject of today's kind of maybe part of that conversation today would lead into Emissions Testing Center program, and maybe you will learn more in the next section. So I won't spend too much time on that. But I would say that this is a unique platform where industry, academia, and government has partnered to essentially deliver something that has never been done. It's kind of offering free of cost lab and live environment testing and validation platform, along with the commercialization support. It's also being supported currently by Alberta government, so we are very thankful for that. Originally, I think there are all of our funding partners have been listed here. So originally it was federal government and then Alberta Innovates, and currently it's been supported primarily by Alberta government. It's been running since 2021, primarily I think in operation since 2022, and since then we have over 100 plus users been using this and getting benefit out of this program. Finally, this is our Clean Tech Ventures Fund. I did mention about this in the beginning, $50 million seed Series A fund up and running for last 4 years. Essentially, these are our 14 investments we have made. As you can see here, they are variety of technologies and startups who are working towards either improving the efficiencies or looking at carbon capture solutions, methane mitigation, water management, so all across the value chain of the natural gas. It's also been supported by the industry itself. So we have Tourmaline Oil and Birchcliff and ARC Resources from producers who are the limited partners in this fund. And then we have others from the downstream, including TC Energy from the midstream, who's been supporting this. I will close here. If anybody has any questions on this or want to learn more about the platform itself, feel free to connect with me afterwards.
Thank you. Can I ask Ian to come on stage, please?
I'll be fast, 5 minutes. Someone signal if, click. Okay. So I'll go through this fairly quickly about the Emissions Test Center lab and what we do there. So it's 2 branches. There's modeling and there's physical testing. So we'll go through the modeling, what happens in that part, and then we'll talk a bit about the physical testing. So in terms of the modeling, we do physics-based modeling. So FD type modeling of, and this happens to be West Wolf Lake gas plant, Tourmaline's facility. And so we do modeling of that, looking at what can happen with respect to emissions. And so we're looking at really digital twin type technologies where we take into account weather data, so wind speed, temperature, and other things into account. And out of that, what you get is you get these digital twins where you are modeling where methane goes. Now, you might say to yourself, why is that useful? Well, it's useful for placing sensors in a plant, for looking at where you potentially will have methane go within the system, and also for how does the built environment affect a plume. So, you know, many of the plume models they use for inverting concentration data and wind data to a actual release rate is based on these fairly simple but very quick to calculate plume models where they invert that data to a release rate, and these are based on open field type plumes. But in the built environment where you have facilities and you have trees, this actually differs. So we've done a lot of work to now understand that with respect to small scale turbulence, larger scale turbulence, the larger air pattern flow, taking into account trees and other things and transport. So that's digital twins. And then out of that, you also look at individual units within these systems, so plant like a flare stack. So we've looked at purge reducers in there to understand what does a purge reducer actually do within a flare stack. And out of that, you can then design better purge reducers or better things to do on that flare stack. Another side of it is machine learning. So this is towards the area of predicting emissions monitoring. So you can do the device-based where you're measuring that, but you can learn. You can use machine learning algorithms to understand these concentrations and in fact predict them with high fidelity. So you can take into account seasonality and other things, and you can train these models on various time scales to then be able to predict what is going to happen on average, given no black swan events or other things that might happen within the operation. So we've done this now for quite a lot of data within field sets and also airshed sets to understand how to model that. Now on the physical side, we have labs. So we have 6 total labs. of them are devoted to emissions test center lab activities. We also have an external garage, so we can do things in the back of the building for ambient testing. And we just completed our first parking lot test. So we've now taken over a parking lot temporarily, where we shut it down and we run tests in there. And we have to do it on a weekend because it's the only time the university will let us do it. But the thing is you know, we've scaled up, and certainly we've seen an amazing amount of benefit in looking at things at small scale, so in small contained environments within the lab, where we can go from -40 up to +100 degrees and test devices in there. And when I say devices, actuators, sensors, OGI cameras, et cetera, lots of things. We can test in there to basically understand them under severe weather conditions with respect to temperature. So we can expose things. So we have lots of stuff within the lab. We are very flexible. It's kind of like a Lego kit. So the way we operate is we have a whole host of stuff from the past, but if we need to, when a company comes in, we will acquire what we need, take our stuff, and we will then form what they need to do their test. And we, in fact, build all of the architecture around, the infrastructure around their device. They bring their device in, they slot it in, we connect it, and then we run the test. We get data. Out of that data, we then write a report on how the technology performed. And the mindset in here is we never talk about, you know, if it didn't work. What we talk about is, if it didn't work, how do we make it work, right? So there's a part of this which is about, you know, fixing stuff. So if something didn't quite work, we want to help to make things work. And the other side of this, we take no IP, right? So all IP is owned by the vendor, right? The company that came in to test that technology. So it makes it quite an exciting place to work for the students and the postdocs and the others, because they're working with these small companies to do things that you don't normally do in research. They're testing technology, inventing stuff, making it work, and they have to do it fast. You know, so in that way, we have to respond quickly to the needs of these companies. So here's some photos of stuff happening in the lab. And in summary, we provide a safe space for people to do things within lab environments where it's controlled. We have modeling that happens. We have physics-based modeling as well. We validate early TRL technologies, help to get it to the next stage where it can graduate from us to go to the field. All right, thank you.
Well, thanks, Ian. So for those who don't know me, my name is Irvin. I work at a company called Tourmaline. I'm an engineer there, so, that's back. So for anyone that doesn't know Tourmaline, we're Canada's largest natural gas producer. We're also Canada's 4th largest midstreamer. Bunch of stats on the board there, but we'll kind of jump into the program. So Tourmaline is one of the 3 parts of the ETC. We look after the field piloting and testing portion of it. We do it across all of our Alberta assets, so we have wells, facilities, and as well as we do stuff with drilling and completions. We have a few specialized assets, part of it. So West Wolf Lake is one of our gas plants that should I move it up? Can you hear me now better? Thanks, Blake. West Wolf Lake is one of our gas plants, so we've retrofitted it with a whole bunch of additional measurement so that we have a good idea of what the emissions profile is of the facility to make validating technology a little bit easier for us. We also have a vent site, so we do this in collaboration with METEC right now as well, but this is a control release site to test and validate kind of perimeter monitors, point source monitors, cameras, variety. So to help with quantification as well as kind of building those international collaborations. We also have a mobile lab, which we call a continuous emissions monitoring trailer. This is primarily used for testing engines. So we do have a really good working relationship with Caterpillar and Waukesha, as well as a whole bunch of other kind of combustion emissions type of devices. Just give a kind of an overview of the scale. So we've ramped up quite a bit in the last couple of years, thanks to the Alberta government funding. So we're currently at 106 different companies in the program, and we've ran a little over 100 tests. Just because this is an Alberta-focused area, or Canadian-focused area, about 60% of those 106 companies are Canadian. We see a high rate of commercialization. I never really like using this because by the time you get to our site, you have to meet the same requirements as sites. So our commercialization definition is probably questionable, but yeah, if anyone has any questions, going to run through this pretty quickly, but Scott's on the panel after, so you can bug him.
All right, thank you, everyone. I'm gonna skip those introduction as Akil mentioned everything about the NGIF ETC under the NGIF, but I'm just gonna mention that the focus is on the methane technology, as you already learned about the presentation. So the commercialization support program is complementary to the lab testing and field testing. So technology go get tested, find a solution, improve their solution, validate it in the field, and then we want to help them to get into the market faster. And the way we do that is through the 4 pillars of commercialization. This pillar are designed to serve all the methane technology. Also, some of them are competitive. So the first pillar is technology landscape, which is an interactive map and database of methane technology under development globally. It's going to be accessible in 2026. I'm so excited about this. The map is helping to match the solution with the emission source and find where it can be utilized. Then we have this commercialization adoption playbook. This is again is designed to serve the broader group of stakeholders, all the technology developer, methane technology developer, as well as the adopter, the funder, investors, and the other association player in the innovation. It's an actionable guideline document to help technology to understand what are the barriers as they are growing toward the market and commercialization, and how they can find help, get solution to pass that stage and get to the market faster. Then we have the technology adoption platform. This is one of the competitive program we are having. It's targeted technology, methane technology at TRL 7 and above, being tested at the field already. They come to the program with the industry champion, who is the operator who has used that technology, so they're willing to share their experience with the other operator and the investor in the room. And this is going to be through a pitch presentation day with lots of operator, investor, and other association present in the room. Then we have the technology exposition. It's again kind of competitive. We are trying to remove some of those barriers for technology provider to get into the industry and go to those events that are normally industry get-together, like a conferences or trade shows. So some of the time it's expensive for them to go to those events. We are trying to remove those barriers and enhance that exposure. And one of the other things we do at the NGIF is this quarterly Tech Talk series. It's a 1-hour virtual webinar. We are trying to spotlight technology, share the knowledge, or address some of the concerns we are hearing from different stakeholders, mostly from the technology provider. Our next webinar is on December 10. It's on investment. I'm excited for that because I'm going to learn about investment through that webinar as well. The QR code would take you to the registration page. Yeah, I think that's all, and I'm so excited for the panel conversation. So, yeah, as the chairs are coming on, I'm going to ask Scott, Ian, Akil, and Wayne, please join us here. Thank you.
I'll stand up. Yeah. That's okay. That allows me to talk and take notes and walk away if I have to. Thank you, Sam, for the introduction, and thank you to Mila for the opportunity to host this panel for 30 minutes. My name is Wayne Hillier. I'm Chief Technology Officer at Modern West Advisory. We're a small shop here in Calgary, and I've had the great pleasure of working closely with these three gentlemen over the last 4 years. I was invited to an early discussion on ETC scope, and that was January of 2021, if I remember, and we've been involved ever since in an advisory capacity. And I got to tell you, it's an ideal job. It's not my money, it's not my plant, and I'm old enough where I'm not insulted if people don't take my advice, but I give my advice freely, and it's been a great partnership to date, and I'm very proud and privileged to be here. Today's a pretty important day. You might have been busy here, but there was a big announcement between the federal government and the province of Alberta today, an MOU committing to collaboration and investment in the province, and I think that's pretty important, and we've been waiting for this, frankly, right? So there was an announcement about a new bitumen pipeline, plans to expand and grow production in this province, and indeed grow the exports of our energy globally, but beyond North America. There is a commitment to the world's largest CCUS plant. There's a commitment to thousands of megawatts for AI power. And there's a high-level announcement of a pending methane regulation, 75% off 2014 by 2035. So my question for each panelist is, given that you had time today to follow the news release and read all the headlines and the details, what does this seemingly new collaboration between the province and the federal government in infrastructure, in growth, in innovation, in collaboration mean for natural gas, but also, more importantly to this discussion, mean for the ETC and innovation? So maybe start with Scott.
My favorite part about being on a panel with Wayne is that he just asks whatever questions he wants.
These are the questions I would want asked of me, so if you can't answer them, I gladly jump in.
So I think it is a great and important time for Canada and for Alberta. Really what the announcement was today, and I just came from there on the way here, was Canada becoming an energy superpower. And I think from an Alberta perspective, I can't imagine anything more exciting than that. And it sounds like we're doing everything real and putting a real program together and a real collaboration together to be able to do that together as both a federation, as Canada and as Alberta. So that's beyond exciting for this city and for Alberta and for the country as well. So that's great to hear. To kind of get to your other part, what does that mean for natural gas? I think it means really positive things for the natural gas sector in Alberta. Obviously, there's a number of LNG projects that are part of the major projects list, so that'll be exciting it's exciting that we have LNG Canada up and going, but it's even more exciting that we have follow-up projects that are coming behind that as well in order to have natural gas leave North America and go to Asian markets and possibly even European markets where that gas can make meaningful differences in people's lives. So that's exciting as well. As far as like in the methane space, I think there's not a ton of details in the MOU as far as what it means in the methane space. I have some speculations. I think that's actually a high-level equivalency agreement. I don't think it's like the equivalency agreements of the past as far as like-for-like regulation. I interpret that as essentially the federal government passing it back to Alberta to say, you write the regulations, but they need to hit those targets. So I think we'll see that be defined over time. That's my speculation without a lot of insight, but I think that's the way it looks. The good news about that is that's happening quickly. The target for when that's going to be negotiated is by April 1st. So we're not sitting back and waiting very long, and all like that whole list of targets, everything was essentially April and July. So I think we're getting a lot of answers really quickly on what this MOU means.
Thank you. I'm sorry. Thank you for that, Scott. Akil, same introduction, maybe an answer more specific to collaboration and the value of relationships in innovation, academics, industry, government, tech solution, tech providers.
Yeah. So I wish I could say I was thinking the same, Scott. But I wasn't. So what I think part of the announcement today, I feel gives me very kind of a, it's an encouraging announcement, and it gives me really good feeling about it, because it relates to what Alberta has been doing over a number of years in reducing emissions, and the leadership of Alberta in doing so. It kind of substantiates the efforts that Alberta has put in innovation and getting those technologies ready. And I feel that needs to continue. And programs like, and the ecosystem in here in Alberta needs to kind of further thrive to look at how to kind of further reduce emissions. So it's about, do you really need those regulations to reduce emissions? And I think the statement today is, you really don't, or there might be an opportunity for innovation to move forward, and technologies to move forward and help reduce emissions without thinking about too much about the tough and those kind of regulations. So that's how I am looking at it right now.
Thank you for that. Ian, same.
Yeah, same question. Well, from an academic point of view, it seems quite exciting. You know, I think that what I see is potential for large investment in innovative activities towards cleaner energy, right? So there's a huge amount of benefit there for Alberta and for the nation. And, when I think about that from a university point of view, we always think about, well, there's the research part of it and innovation. So, it spearheads, and makes deeper already these, we have the intimate relationship we have with, academia, association, and industry, working with government who funds us, makes this an incredibly productive program, what we have in the ETC lab and field programs with the accelerator there. The other one is talent creation, right? So from a university perspective, we're always looking at, students and graduate students, postdocs, the next generation workforce. So what I also see there is I see a very positive sign that there's going to be opportunities for young people and in this industry, that things are going to surge, that there'll be a need for innovative young people who will do stuff, right? So from the point of view of talent creation, this is very important to see happening.
I think the Prime Minister may have said that he's super excited about the sciences and left the other parts of talent creation out. And I think he kind of put his foot in his mouth a little bit there.
Yeah. There's a whole side.
But he was very excited about how much we're building, how much is going on, and how much we need engineering and sciences and all the people and all the things to build that. And then he had to say, I also like the arts afterwards.
And we will remind him of those things, because deployment of solutions is a community-based thing, right? It's not just about the science and technology; it's about people actually adopting and using stuff, right? So certainly, we have to take communities into account.
So I'm going to build on that a little bit, Ian, if I may, and then come back this way with similar questions. So given the new context that we're operating in, and your involvement for 4 years with the ETC, what's been your most satisfying moment today? And I'm looking for a link between your pure and applied science, or research rather than lab, and field deployment, right? Which is really Scott and Eamon's role, is that getting things out of research and into the field. What's been your most satisfying experience with the ETC?
Well, I think as a professor, and I think many professors would agree with this, is the deployment of what we do. So, we do testing in labs, and there's a lot of fundamental scholarly stuff done, but to see it become useful and then deployed, in my view, is the most satisfying thing. So, an example within the ETC program is kinetics, right? And so a whole lot of lab testing, still doing testing. So they're a repeat customer for us. And we do an amazing amount of testing on their devices, their actuators. and they've gone beyond us to the field for field testing. And so what you see there is you see a transition from what was a model of testing in lab where, yeah, there were issues, but they were fixable. And you could rapidly test and get them to a point where, ooh, now let's go to the field. And then they test in the field. So I think the thing is, what is most satisfying about what I do at the university is seeing where something at beaker scale or small scale within a lab in a fume hood is taken to the point that it is a machine doing something of benefit. It creates value, it creates jobs and all of that. It's very satisfying to see that.
And maybe I'm going to jump to Scott then on the deployment side. So similar question, what's been the most satisfying part of the last 4 years? What resonates with you from a deployment perspective?
The most satisfying, like, overarching piece is how big and how fast we've gotten as far as the ETC. The capabilities that we have and how quickly we can bring technology through the ETC, how we built the systems to be able to quickly contract. We avoid any of the difficulties with IP, and we get technology tested and validated in an extremely quick fashion. So that's probably the most satisfying thing. If we're going to say down to a day, it would be when we planned out for the minister to show up on site and had 10 technologies there all at the same time, and that came together in 3 weeks. We built that crazy computer screen within that same time frame and took it out to the field as well. So incredibly proud of the team and what they accomplished to pull that together so quickly. And really just what we've been able to execute as a whole is something that I'm extremely proud of.
Okay. Thank you for that. So, and Akil, maybe link in some of the other NGIF activities, NGIF grants, for instance, anything that's particularly satisfying for you that you've watched go through the process and end up being deployed at the ETC?
I think from a program level, it's so satisfying to see that it's working and it's actually making an impact, and it's a real impact you could see every day. You could see these kind of technologies moving from lab to site to then working towards hustling to get into their first customer. So that's so satisfying that yes, they are able to get customers now, and now they are growing their business and scaling up. So from a program perspective, that's great. What we as NGIF is trying on our end is from an ETC program itself is to work towards helping startups get their first customer. So that's where we are working, and that's where when we see those success coming out, those are really kind of gives you good feeling and that everything is all right.
Thank you for that. Sorry, Scott, go ahead.
Sorry, I talk too much. One of the cool things about it is, like, we are the steering committee for the ETC, and one of our obligations is to inform the Alberta government as, like, what's happening with the money that they're investing in and how it's working. Being on those steering committee meetings is kind of crazy because we're, like, essentially having Alberta drink out of a fire hose of, like, all the things that we've accomplished every single month, and, like, trying to get that fast enough to where we can actually communicate all the different things that the team has executed and all the different outcomes that have happened has been incredible. Like, you can't even, like, you have way too much information to give them in an hour type of thing, and that's, like, what comes out every single month.
You know, if I may, I'm going to actually add to this and answer my own question.
Wayne, what do you think is the most...
Well, I was going to ask that what's been the most satisfying part?
Yeah, the satisfying.
Well, I'm glad you asked, because I have some experience with the ETC. I do want to emphasize just the value and the satisfaction of having Tourmaline as a site host and the commitment they showed to this from the top of the organization downtown. Scott and Eamon, I tell you, they know how to get things done. Our learning curve early was we struggled to get things deployed. But now it's a well-run, well-oiled machine. And it's because of the decision-making done at the site level and the corporate level by people like Scott and Eamon. So I want to thank them, but also express my gratitude. But as an example, I see this over and over again. I mean, part of the growing pains, we thought, deploy and we're done. To just give a technology access to real data and they'll be happy and they'll go home. But the truth is, it's seldom like that. In this country, in this province, in this industry, you really need to test in 4 seasons. And sometimes you have to test over multiple years because you have to wait a year to get another winner. And there are technologies that have learned and keep coming back to learn more, to advance their technologies, to improve their technologies. They may be commercial, but there's always an opportunity to get better. So that's particularly satisfying to see a technology advance to commercialization, but stay as part of the program to get more and more information. Excuse me. Now, building on the opposite to satisfaction, sorry, it wouldn't be opposite. Let's talk about the challenges that you may still face. I just said it's a well-oiled machine, but there are still challenges to get technologies through academic, through the university, and into the field. So maybe starting with you, Akil, what challenges do you still face in the NGIF programs, particularly ETC, and if are there any obvious solutions to those challenges? And if you'd rather pass the question to Ian while you're thinking about it, because I know he faces challenges like nobody else.
Yeah, I don't want to share too much. So yeah, I have different type of challenges. But what I would say from an NGI perspective, because our role in the program itself and getting to that role was in itself an evolvement of an ETC. And I should probably thank both Scott and Ian who pushed NGIF to kind of think outside the box and say, okay, what can we do as part of this program to add more value? So we did kind of through this Alberta funding, we did had this commercialization support program offered. So we are right now probably going through that learning curve that both Ian and Scott would have gone through in 2022 with their own programs, but we're observing some of the challenges in terms of it's easy to say, go and speak with the customer, but then it's so difficult to have those meetings and have some constructive feedback and then getting the first order. And it's so difficult to kind of relate those kind of journeys of the startup itself to say, okay, how to navigate the procurement cycle. How those are sometimes for some operators it would be too long and you would become kind of knocking different doors and may not have a kind of a fixed answer. So we are also learning that and then fine-tuning our program to help support startups navigate those barriers in the right manner. So I don't have like a really point-to-point answer to you, but I have a path to go there.
I will come back to you and ask for more detail. But Ian, can you address the same question?
I think, we've learned. So we've grown and we've learned. And in fact, we've grown. One of our challenges is that we've got a lot of companies that want to enroll within the ETC program. And that's both lab and field. So on the lab side, certainly, we're booked till February next year and have tests planned. We're procuring equipment all the time to prepare and assemble equipment ready for tests. And, and all of these are custom built from bits we have and what we order. So this is certainly it's in a way a good challenge to have. So we know that, that's happening, but it does represent a challenge for us, that amount of growth. The other one is the nature of the testing. So we're seeing a kind of interesting trend here where, in previous time we could do everything within a lab. But now we're getting more and more requests, can we do it in the back, in the ambient testing, in the garage? And can we do it not just for 1 week or 2 weeks or whatever it is, or multiple tests scheduled? Can we do it for 3 months? Can we do it for 6 months? So ambient testing and, now moving to the parking lot it's representing a sense of growth in the type of testing needed, which again is exciting. I mean, we love participating in this because it's more meaningful for us. It's actually more impactful in many ways for even all the students, the postdocs, to participate in such tests. So these are good challenges to have, but they are challenges.
Scott, would you like to add anything?
Yeah, I'm virtually going to echo Ian. Our biggest challenge is the amount of companies that have interest, which is a great challenge to have. It's just really hard to have the capacity to keep up and the funding to keep up. And ultimately, you can't really do that. You kind of have to have a bit of this is how many we can accomplish at any point in time, and then have a little bit of a waiting list. So our biggest challenge is that for the first time ever, we may have to say no or not yet, which we haven't done, and we've been very, very proud of that in the past, that we've never said no to anyone, but we might actually have to say yes, but in a little while.
I have not known Eamon to say no.
I know, he will not say no.
And
But you have known him to go over budget and spend budget we don't have yet.
I better get that expense account in quick, right? Speaking of which, sorry, I should do a time check. I'm not. 10 minutes. And is there any forum for questions from the thousands of people who are online watching? Because my Facebook account's just lighting up right now. And to ask from the audience here, can we go online as well? No. Can you make one up? Just so I don't. So a common question I get is, why do you spend so much time with Eamon? And because people will see us either in the field together, in sessions like this, or lunch, or, well, I'll leave it at lunch, but, and it's really mutual respect and driven by the same goals of getting things done and making a difference. And maybe to recap for a second, because Sam delivered the message, and we've been talking in general terms here, but the ETC is all about methane, but it's technology deployment, advancement and deployment in methane detection, methane quantification, and methane mitigation and control. So all aspects of methane can be brought to the ETC, so keep that in mind. Initially, it was all about primarily detection, and this year, a heavy shift to mitigation. And maybe it wasn't clear, but I think is worth mentioning. The initial construct was the West Wolf Lake gas plant, one site. Then a 9 of 18 site was built that is a dedicated control release site. But Tourmaline has actually offered up their entire assets in Alberta. That's a fair statement, right? That if a technology is brought to the ETC and is best suited at a battery or a compressor station or a gas plant that's not 10 of 3 or 9 of 18, Tourmaline will gladly deploy that technology in a new facility. So it's not one or two sites, it's an entire corporation, or at least the corporate assets in Alberta, I think it's fair to say.
Yeah, and even our funder allows us to go into BC a little bit. So it's funded by Alberta. We kind of have to keep it at like 10, 20% or less. But we are allowed to go into BC if we need to as well.
So that would be a good opportunity for Keel to work with the BC funders so Eamon doesn't have to say no. Okay. Maybe let's unpack this 2030 versus 2030 versus 2035. Okay, so we've been, I think it's fair to say, working on the premise that federal and provincial regulations would be based off of some historical baseline and come into effect or have the reductions met by 2030. Today, for the first time, I think, publicly rather, the year is 2035, so 75% reduction off a baseline by 2035. That 5 years I think is pretty important. You know, if it was 2030, we may be, the crunch would be supply chain issues. Can we get the equipment on site deployed and mitigating methane before 2030? And it really kind of cuts short innovation. Does that 5 years provide a very active window, an opportunity for acceleration of innovation, so we have new solutions, better solutions, more cost-effective solutions available by the end of the decade so they can be deployed in the first 5 years of the next decade? Open question for anybody who wants to take it.
Yeah, I'm excited about it. If you look back at Alberta or even the world's entire methane journey, we're only 10 years in right now. Like when methane regulations were first kind of proposed in that 2015 kind of time frame, we're about 10 years. And like, look what we've accomplished. Like some of the most incredible things are like when people come and see what was done at the ETC, they love the robot dogs and like the things like that, or like when we're flying helicopters in order to detect methane, or kind of the satellites in space that we're launching in Canada. Like when you really think of like what this innovation community accomplished in that the first 10 years, it's pretty incredible. And it's been at a very, very fast pace, and you've seen innovators today kind of talking about all their technologies, and there's been some really amazing progress. So the next 10 years, so now instead of 5, we got another 10. Just think about what we'll be able to accomplish after that. So I'm super excited for the fact that we can keep doing this for the long term. And the interesting thing is that this journey isn't a linear journey. As we get kind of closer to 75, everything starts to go exponential. And we're competing on what I would call a log scale now, where every step further becomes about 10 times harder than the step before. So that kind of piece is like, I'm super excited to have a little bit more time to try to tackle some of that log scale, where like what we were able to accomplish to get to 45% or 75% or wherever you think we are today, that next step, like if it took 10 years to do it the first time, it actually probably would take 100 years to do it if we did it at the same pace. So I'm pretty interested to at least have five more. So super excited.
Good answer, Scott. Thank you. Ian or Akil, would you like to build on the question, the importance of the 5 years?
I mean, yeah, I think, when I look at deployment of technology and that sort of thing, the 5 years is incredibly valuable, especially for deployment. So as you said in your comments, I mean, the thing is we've got 5 more years to build. We had 5 years more to build solutions and deploy and realize a 75% reduction. I don't know how you do that. Especially because the fruit is higher up the tree, right? So the low-hanging fruit was gotten, and now we have to go higher. So I think this gives a wherewithal to now achieve it. And given the momentum of the past, I suspect we may hit that target prior to 10 years. So I think that, given the behavior of the past, the industry, the government and others, what's driving all of this, it may be not 2035. It'd be wonderful if it's 2033 or 2032.
Yeah, like that's fair to say. Like the regulation might be 5 years old, but all the other policy and all the other things aren't. Like you saw the Alberta government put in the ERA funding in order to reduce emissions, and you see the offset program as well, and that the offset's going to grow into vent stack or surface casing vent flow capture and kind of all those other things. So maybe the prescriptive regulation and the stick is a little bit 5 years down the road. But I've never seen Alberta take their foot off the gas on reducing methane emissions across the board on all policy fronts. So maybe the stick is a little further down the road, but those carrots and those meaningful things that allow this space of people to make meaningful impacts, I think is still running full tilt. Like I haven't heard more announcements. Like it still keeps going. Like there's no stop to funding.
Blake did give me one new announcement, and I'm really not sure if it's the place to say this, so I'm going to pass it to Scott.
I'm not going to say that.
You don't care? You don't care. No, I'm not saying that.
It will be no secret. You want to know what this
So there's some good news coming out of Ottawa. Look at the news tonight, okay?
Yeah, look that up for yourselves. We can't say that on the stage.
That's a real good note to end the panel discussion. But maybe, do we have time to open up to anybody here? Are you sure? Anybody here would like a question? Ask a question? What's that? Oh, well, Blake, it's all yours, buddy. Yes, please.
Okay, hi, I'm Kate Easton. My question is, to what extent is the cost of the solutions a problem in terms of getting to that 75% target? And to what extent is it actually just technological feasibility of capturing those emissions?
I would say they're one and the same kind of statement. So like when you're saying that you need to get to 100% adoption or to 75% adoption, and you're thinking about any technology, let's like start with a computer, for example. When the computer was first invented, we had a computer, but it was the size of like this room probably, and its cost was like tens of thousands of dollars. And now everyone has walking around with one in their phone because it got cheap and it got small and it got better. So in order to get to that 75% adoption, we need all those things. We need it to get cheap, and we need it to get small, and we need it to get better, and we need it to get adoptable. And in order to say that we can hit that type of like increase and have 75% or even like some of the discussion papers that the federal government had before was really 0%, like venting is prohibited. We need incredible solutions that are incredibly cost effective and can fit into places and solve more problems than they had before. So I would say the two are the same. Like we need the innovation to get the cost down.
Yeah, for sure. But I mean, are there things that we just actually don't know how to do yet in terms of?
There are definitely things we don't know how to do yet. Like I spend a lot of time talking about how the proposed regulations were not very achievable. Like they're definitely not achievable in my eyes at least. So yeah, we need a lot of innovation. We still have lots of things that we need to figure out how to do. Like things like methane slip are still really difficult categories to try to find solutions for. Tanks will be difficult categories for some time. And then just chasing smaller and smaller and smaller amounts of methane like that gets infinitely impossible eventually to where you're down to the very last molecule. So absolutely.
But it's mostly cost that you need the technology to improve so you can reduce the cost.
Yeah.
Well, yeah, no, it's both, because you need a lower cost technology that's more effective. So we need to advance on both, especially if you're looking at lower concentration methane sources and things that are harder to achieve just from a physics chemistry point of view. So we need to have technologies that achieve things better, so more efficient, which correlates with cost, but also they have to be more effective in that they do more with less, so to speak. So I think both are incredibly important in enabling what we need to go to the future. The other side of it is what I think is important is the recognition of the challenge, because sometimes, and that's what's kind of interesting in my view when I look at the methane, kind of the natural gas industry and methane reduction set of activities. There's a very clear understanding of the problem. And that's what's driving the innovation in many ways. So, the low-hanging fruit, go after, it's easy, it's lower cost because it's easier and all that. And now it's about ramping up to the next level of that. So I think it's, being more effective with less and lower cost.
And costs are weird for this space because there's so many devices. So like when we're talking about sources and devices, like it's tens of thousands of devices for each operator. So like when you take tens of thousands and multiply it by any number, that gets pretty huge really quickly. So if someone's like, well, it's just a $40,000 thing, or it's just a $100,000 thing, or a VRU is just a couple million. Like when you're talking about multiplying that by tens of thousands of things, that becomes really impossible because of cost at a certain point as well. So that's what's unique, and like that's also where I think Alberta is a little bit unique as well. Like we actually have a huge amount of sites. We've been doing this for a long time, and we've got hundreds of thousands of sites, And that's a little bit unique to somewhere like Norway, where their production comes from like 100 and some platforms kind of offshore, where solutions are a little bit easier. So not to say we don't have a challenge that we can accomplish, but it's very different when you have lots and lots of sites. It also makes the methane space a little bit easier, because when you're innovating, you don't have to do one multi-billion-dollar carbon capture project to solve the problem all at once. You're doing little tiny innovations and kind of attacking that death of 1,000 cuts kind of thing. So it's a good problem to have, in that innovation's easier, and you can see that by the amount of companies that come through the testing center. But it's a challenging problem because it just multiplies by so huge of a count.
Great question. Thank you. I think we're out of time now, right? My apologies, Alberto. I thought we had time for one more question. You should know me by now. Deadline? What deadline? Despite the questions, I think the panelists did a great job answering. Let's thank them for their participation.